We're doing section 4.6, continuing graphing trig functions. This time it's going to be all the other trig functions other than sine and cosine. So if we're going to start with tangent, knowing that tangent is sine over cosine, or y over x, which we did a couple sections ago, then we know that we're at for the bottom of our fraction, so cosine is equal to 0, then the tangent could be has to be undefined. So just plugging in some values here into the tangent function, we find that negative pi over 2 and positive pi over 2 are both undefined because that would be where cosine is equal to 0. And then at negative 1.57, it's negative 1255.8, so seriously small number. Negative 14.1, negative 1, 0, 1, 14.1, and 1255.8. Now something to recognize here is that it's symmetric, and to recognize that halfway between negative pi over 2 and 0, so these two values, those are the nice whole numbers, the ones that we're going to actually be graphing. And what we're going to do with those is whatever number is in front of the tangent function, in this case this is just tangent of x, so 1, that's going to be your values. If you notice, you have negative 1 and 1. So that's what you're always going to use, and we'll do some examples of that in a little bit. But just looking at the graph then of the tangent function, you see those asymptotes at negative pi over 2 and positive pi over 2. And we see that this is periodic, that it's going to keep repeating itself, look exactly the same. So when it starts to repeat itself, what is that distance from negative pi over 2 to positive pi over 2? This is pi. So the period of a tangent function is pi. The domain is everything except pi over 2 plus n pi. That way we don't have to write a lot of them down. We can just say that it starts repeating itself every pi, starting at pi over 2, where n is any integer, so it could go negative as well. But the range is everything, right? It's all real numbers. There's nothing that the range couldn't be. Okay, so let's sketch a tangent function by hand. Let's start by sketching tangent of pi, or x over 2, excuse me. So since vertical asymptotes occur everywhere, pi over 2 plus n pi, if we have a tangent of bx minus c, what we're going to do to find those two asymptotes, like we did with sine and cosine to find the starting and ending point, we're going to take whatever is after the x, so the bx minus c, and set it equal to negative pi over 2 and positive pi over 2. And that's going to give you your starting and ending points. So with this specific example, we're that whatever is after the tangent function is pretty much what we're doing. So in that case, it's just x over 2 equals negative and positive pi over 2. Solve it, and we get negative pi and pi is going to be our asymptotes. So we're still going to find 5 key points for the tangent function. They're just going to be different than the sine and cosine 5 key points. Starting at those asymptotes. So our we're going to start with an asymptote. Here it's at negative pi and pi. The middle point is always going to be an intercept. It's always going to cross 0 in the middle. And then the other 2 points, the other 2 points of our tangent function are just going to be points that we're going to end up graphing. And remember what I said on the last example, or the last page, was that whatever number's in front of your tangent function is going to be what that point is. In this case, 1. So tangent function is always going to be increasing. So we have to remember, because one of these points is going to be positive and one of them is going to be negative. First off, the x values are okay, we can do those. Asymptote's undefined and the intercept is 0. Easy. But the points, remember I just said one will be positive and one will be negative. If tangent is always increasing, that means that the first point is going to be negative and the second point will be positive. Okay, now we're going to do our best to draw this. Missed a little bit. There. Okay, so all we need to do, just like with sine and cosine, is just one cycle. So that's all we need to do. Again, here are our 5 key points. Okay, let's do another one. This time we have -3 tangent of 2x. So that negative is going to throw us off later, but let's just start with finding our first and second asymptotes so we can get one cycle. So we take whatever is after the tangent function, in this case 2x, and I set it equal to -π/2 and +π/2. So our cycle is going to be from -π/4 to +π/4. And you can average them out to figure out those middle values, or you might be getting good at it, where you can figure out what they are. First and last are always asymptotes. Middle one's always 0. And the other two are just 2 points. And the points are going to be the amplitude, that number in front, which is 3. This time we need to be careful, though, because remember, tangent's always increasing. So the first one should be negative, the second one should be positive. But that negative in front flips it over, which means instead of going from negative to positive, we're going to go from positive to negative. So this should be +3 and -3. Okay, so let's go ahead and graph these. Our asymptotes are at π/4. So it's going to be a skinny graph. 0, and then 3 right in between. Okay, so that's what that one looks like. Okay, so now we're going to do cotangent. It's really similar to tangent. The only difference is where the asymptotes are located, because this time we have sine on the bottom of our reciprocal function. So it's wherever sine is equal to 0 where our cotangent graph will be undefined. So this time the asymptotes occur at n pi. So 0, pi, 2 pi, 3 pi, etc. So when we want to find those first and last asymptotes, like we did with the tangent, this time we're going to set whatever is after the cotangent function, so in this case it's x/3, we're going to set that equal to 0 and pi instead of -π/2 and +π/2. And that's going to find our first two. So 0 and 3 pi is going to be where our two asymptotes are located for our 5 key points. Otherwise, it's exactly the same. I guess the only other difference is that the cotangent function is pretty much just flipped over. So instead of being increasing like the tangent function was, the cotangent will be decreasing. So the first point will be positive. Asymptotes don't exist. Intercept is 0. Our first point, remember I just said it will be positive, so 2, and -2 for our second point. When they get really wide like that, my graphs look pretty goofy, so I apologize. Okay. we're going to talk about the two reciprocal functions, cosecant and secant. And they're going to have asymptotes as well, and it's going to be wherever, cosecant will be wherever sine's equal to 0, secant will be wherever cosine's equal to 0. The steps that I want you to go through every time is to graph the corresponding sine or cosine function, and then all you're going to do is wherever there's a 0 to the sine or cosine function is where your asymptotes are going to be. So I will show you the process, but really you're just going to go through and graph the original. So we're just going to start with cosecant of x. So we're going to go through and graph not only cosecant, but we're going to graph sine first. With the 5 key points of sine, and then go from there. So it's going to be intercept, max, intercept, min, intercept from 0 to 2 pi. Now the difference then, once you have the 5 key points for sine, everywhere you see a 0 is going to be undefined for cosecant, but the other two numbers will be the same. So let's go through and sketch our sine curve. And then everywhere there's a 0, turns into an asymptote. The other 2 points stay the same, but you're never going to cross. Your graphs will never cross. They will touch. So at this point 1, that's now going to be the minimum for what looks like a parabola. I mean, kind of. And then same thing at 3 pi over 2, it will look like a parabola, but it's not going to cross the graph. It's going to go the opposite direction. So it'll be an upside down parabola. Okay, so that's what this cosecant graph looks like. And secant will be last. So we're going to go through and graph cosine and then graph secant off of cosine. It's always what you're going to do. Even if there's translations, you're going to go through with those translations of cosine to graph the secant. Cosine starts at a max and ends at a max. 0 to 2 pi. I'll go through and graph cosine quick. And then off of that, everywhere there's a 0 turns into an asymptote, but the other points stay the same. So asymptote. So it's going to, this is a little bit different because it's not, we're not going to draw in the whole parabola. You can if it makes you feel better, but I really only need you to draw the same half that is showing for cosine. So this one will be the whole one. But otherwise, you're just drawing little halves of parabolas for cosine. Secant, I mean. Okay, so here's our homework assignment. And that was section 4.6, the graphs of all other trig functions.